The night sky holds many secrets, but few are as exquisitely engineered or as deadly as the ultimate nocturnal hunter. To the unsuspecting prey on the forest floor, it is a phantom. It strikes without warning, appearing out of the darkness with a precision that defies the physical laws of aviation. We have always wondered why an owl's flight is completely, exceptionally silent. But the answer is only the beginning of this creature's story. To understand this predator, we must look far beyond its feathers. We must journey deep into its neurological wiring and its skeletal architecture. Standard birds generate a loud, whooshing sound as air rushes over the rigid, sharp edges of their wings. The owl, however, operates on an entirely different frequency. The secret to its stealth technology lies in three distinct adaptations. First, stiff, comb-like serrations on the leading edge of the wing slice through the air. Instead of creating a massive, noisy wave of turbulence, these serrations break the air down into tiny, quiet microcurrents. Second, a soft, velvety down covers the entire surface of the wing. This acts as an acoustic dampener, completely muffling the sound of the feathers rubbing together. And finally, a porous, tattered fringe on the trailing edge diffuses the air as it leaves the wing, erasing the aerodynamic wake. But this silence isn't just about sneaking up on prey. It serves a much more vital, self-serving purpose. If the owl's flight were noisy, the sound of its own flapping wings would drown out the faint, crucial sounds of the prey below. Silence is the key to its hearing. Beneath those silent feathers lies a parabolic receiver. The owl's facial disc is shaped like a shallow bowl, perfectly designed to funnel sound waves toward its hidden, asymmetrical ears. When a mouse takes a single step beneath a layer of snow, the faint rustle travels upward. Instantly, the owl's biological supercomputer goes to work. The owl's brain acts as a microscopic stopwatch. It measures the minute difference in time it takes a sound to reach one ear versus the other, instantly pinpointing the horizontal location of its prey. Simultaneously, it measures the microscopic difference in volume caused by the asymmetrical elevation of its ears, calculating the exact vertical elevation. Within fractions of a millisecond, these separate signals race down independent neurological pathways, converging in the midbrain. The result is a highly precise, continuous, three-dimensional auditory map. The owl has effectively placed a crosshair on a target it cannot even see. With the coordinates locked in, the phantom initiates the strike. But the hardest part of the hunt has just begun. As the owl plummets toward the earth, it faces a profound physical challenge. Gravity takes over, and velocity increases rapidly. The turbulence of the fall and the aggressive twisting of the bird's body threaten to spin, distort, and destroy that fragile, meticulously calculated auditory map. The solution to this chaos is a masterpiece of evolutionary engineering. The owl possesses a biological gimbal. While humans have only 7 neck vertebrae, the owl boasts 14. This long, highly articulated chain of joints acts like an advanced, living suspension system. Driven by the vestibulo-colic reflex, lightning-fast signals from sensors in the inner ear, complex neck muscles fire off rapid micro-adjustments. While the bird's body twists, drops, and buffets in the rushing air, its head remains miraculously, completely still, perfectly level and locked in space. The biological gimbal ensures the internal targeting map is updated flawlessly, millisecond by millisecond. An owl's vision is just as alien as its hearing. Unlike humans, an owl's eyes are not spherical. They are elongated tubular telephoto lenses stretching deep into the skull. These massive tubes are locked firmly into place by rigid bony housings called sclerotic rings. The structural trade-off is severe. An owl physically cannot roll or move its eyes within their sockets. It cannot glance out of the corner of its eye. It is permanently imprisoned in a forward stare. To look at anything not directly in front of it, it relies entirely on the extreme rotation of its 14-vertebrae neck, swiveling its head up to 270 degrees. But this rigid ocular anatomy provides a massive advantage. The wide cornea acts like an open camera aperture, funneling in maximum ambient light. This light hits a retina overwhelmingly packed with rod cells, the specific photoreceptors designed to detect light and movement in the dark. While they sacrifice vibrant colors, their vision brilliantly illuminates the pitch-black forest in high-contrast shades of silver and gray. Not all owls rule the night. In extreme environments, the rules of the game change entirely. In the harsh northern latitudes during the summer, the sun never sets. Species like the pristine white snowy owl are forced to take the day shift. To protect their incredibly sensitive retinas from the glaring sun, their pupils possess extreme muscular control, constricting down to tiny, sharp pinholes. But for smaller owls resting during the day, the bright sky brings a terrifying new danger. Visually sharp diurnal raptors, like hawks and eagles, patrol the skies above. To survive, smaller owls must become masters of illusion. This defense begins with cryptic plumage, feathers intricately modeled to perfectly mimic the texture of tree bark. When a hawk is spotted, the owl adopts the tall, thin concealment posture. It stretches its spine rigidly upward and compresses its feathers tightly, instantly shedding its recognizable chubby bird shape. It raises its prominent ear tufts, breaking up the round silhouette of its head, making it look like a jagged, splintered stump. And finally, it hides its most glaring feature. Slowly, purposefully, it squints its bright yellow eyes down to narrow, nearly invisible diagonal slits. To the predator circling above, the owl has simply vanished. It has transformed into nothing more than a broken branch, waiting patiently for the sun to set.
Perfected by nature, its neck rotates 270 degrees. A master of disguise, it vanishes into the bark. Built for the shadows, its eye dilates to capture the faintest light, while silent feathers muffle every movement. A perfect predator.
The owl stands as a marvel of evolutionary specialization. It is a creature that has pushed the absolute boundaries of sensory perception. A predator, perfectly adapted to rule the margins of light and shadow. We began by asking why an owl's flight is completely, exceptionally silent. But we have discovered that this stealth is merely the foundation of a much larger biological masterpiece. It is the silence that allows the neurological auditory map to function. It is the biological gimbal that keeps that map perfectly stable during a high-speed dive. And it is those massive tubular eyes that guide the final lethal strike. Every single adaptation is flawlessly engineered for one singular purpose: survival. Whether it is plummeting through the dark, freezing canopy of a winter forest or vanishing in plain sight beneath the glaring midday sun, the owl remains the ultimate silent phantom, a ghost of the forest, forever holding its secrets in the dark.